Okay, I'd like you to find this problem. It's on page 119 of your packet. Deals with a study involving black men who were taking calcium and trying to see the effect of their blood pressure. And again, answer the three questions. What kind of data is it, categorical or quantitative? Is it a hypothesis test or a confidence interval? And what kind of statistics would you use here? What symbols would you use here for this particular problem? Pause the video and read through this problem and answer those questions. Okay, so this is, as I mentioned, a study involving black men and whether calcium helped their blood pressure or not. If you notice, they took measurements of their systolic, which is the top number, in blood pressure, and it's in millimeters of mercury. So this is definitely quantitative data. I don't see the word confidence interval, so I know this is a hypothesis test. And I also notice here that there's two groups here. And remember the last video I talked about how there might be two sets of data, but it's a one sample test in disguise when it's the same people doing the experiment twice. This is not the same people doing it twice. These are two different groups. So this is going to be a two sample test. Okay, because we have two different groups of people. And one group is given the calcium, one group is given the placebo. One of the big things here is to notice here is the fact that the two groups are not the same size. So it can't be the same people doing it twice. Okay, so group 1 had 10 people or 11 people. Group 2 had one more person than that. Okay, all right, and so the data that we're looking for is going to be X bar and S, this mean and standard deviation. If you notice, it's not given to us. We're going to have to go and find that and talk about how this two sample test works with that data. Okay, so again, let's write out our four categories: state, plan, do, and conclude, and let's see if we can solve this problem. So in the state, we're going to write our null or alternative hypothesis. And our null hypothesis should be equals, and just notice this is incorrect. This should be the alternative hypothesis. So this should be HA, not HO. But our null hypothesis is the fact that the blood pressure did not change between the two groups, because remember, it has to have an equal to sign. So if these two groups have the exact same changes in their blood pressure, then the difference between the calcium group and the placebo group should be 0, because they are the same. If they are, in this case, greater than, then that means the calcium managed to lower the blood pressure, because if the calcium is greater than the placebo, means the amount of how far the blood pressure dropped is bigger in the calcium group than the placebo group, means the calcium group had an effect on the blood pressure. Okay, so what we have to do here is write that out into words. So our null hypothesis would be that the mean from our calcium group minus the mean from the placebo group would be equal to 0, because there's no difference between in how much the blood pressure was reduced between taking these two medicines. Okay, one's a placebo, not really a medicine. However, our alternative hypothesis, which I know here should be HA, is the placebo group minus the calcium group minus the placebo group should be greater than 0, meaning that the calcium group reduced pressure more than the placebo group, if it's greater than 0. So we have alpha equals 0.05. It's not given to us. That's the alpha level we always use. In confidence intervals, if it's not given to us, reminder, we use 95%. So they are related to one another. So if you notice, I did change the alternative hypothesis to the correct symbol, HA, for in the state section. Now we're going to go to the plan group section. And again, it's our three categories: random, normal, and independent. If you notice, both samples are randomly assigned. They are randomly assigned whether they get the calcium or the placebo, so the randomization thing is taking place. Normal, we have n is less than 30. Remember, with quantitative data, the magic number is 30 if we want to use the CLT. Unfortunately, the sample size here is less than 30, and we're going to have to check each sample separately. The calcium group, if you remember, was only 10. I believe it was only 10 people, and the placebo group was 11. So both of those are less than 30. So we need to make some graphs here, which I have the graphs here, but I'm going to show you how to do that on the calculator. So I have the data listed here. So again, I created a list and spreadsheet page. And now I'm going to go to the data and statistics page, and I'm going to actually create the graphs. So the first graph I'm going to look at is the calcium group. It gives me the dot plot. It doesn't help. I can kind of look at that, but it's hard to determine if there's outliers here. So I'm going to change this to outliers by right-clicking in the white space. So again, Control, Menu. Whoops, I got to make sure I'm over here in the white space. Control, Menu, and I can change it to what I want. I'm going to change it to a box plot. And I look there and say, aha, no outliers. So that confirms that the data is considered approximately normal, even though that dot plot didn't look like a normal curve. With a very small data set, as long as there's no outliers, we consider almost anything approximately normal. I can easily change this just by clicking down here from the calcium box plot to the placebo box plot. And there's a placebo box plot. Again, no outliers, so I would consider these both approximately normal because I didn't see any outliers. If you notice, those are the two graphs that are sketched here. Left one is the calcium group, right one is the placebo group. And I would say here that both samples are approximately normal because I don't see any outliers. Independent is the second time we've seen this. These people were volunteers. Normally we use the rule of 10 here when it's a sample, but when it's volunteers, we just got to show that the blood pressure in one person is probably not affected by, does not affect somebody else's blood pressure. And that's a pretty logical assumption. One person's blood pressure is not affected by somebody else, even if they're in the same room. Okay? All right, so then we go to our do. Okay, this is a two-sample test. So we're going to write in in words. You can skip this step if you like in symbols, because it's a very complicated formula. So we do not have to write the symbols for a two-sample test. But we do write, and for that reason, we don't do numbers either. Okay? And we just use our calculator. Okay, so when we're going to do this on the calculator, which I'll show you how to do that here in a second, we're going to use the two-sample test. Okay, so if we go back to our calculator, we're going to add a third page here. If you notice, I don't have a calculator page. So I'm going to hit Control Document, and we're going to add a calculator page, and we're going to do the two-sample test. So I go to Menu, Stats, Stat Tests. Oh my goodness, all these tests. Reminder, I keep reminding you, never do 1 and 3. So it's either a t-test, two-sample t-tests, or these two proportion tests. So remember, 5 and 6 are for categorical data only. So prop means proportion, z, which we use for categorical. So in this case, we're going to use a two-sample t-test because we have two different samples, two different groups of people, and it's quantitative in nature. So two-sample t-test. And we have the data. If you notice, remember, it was in the list in the spreadsheet. So it's already in the spreadsheet for us. So we're going to use the data. I'm going to just tell it what list 1 was, which is the calcium group. List 2 was the placebo group. And we want this to be greater than. And we're going to use pooled. I'll talk a little bit more of that later on, but we will always use a pooled t-test here. Basically, it just puts the samples together and calculates that way instead of as two simple tests. Okay, so hit OK, and we look and we find our p-value and our degrees of freedom, which we got to record, and the t-statistic. So these three numbers we record in our sheet here. Okay. So if you notice here, this is where I put in the t-statistic, the p-value, and the degrees of freedom that the calculator gave me. Remember, these are the three values you'll always record any kind of quantitative t-test. Okay. So then we look at our p-value. Whoops, it's 5.6%, not 5.2%. It's greater than an alpha, which is 5%. Probably should put this in parentheses. So remember, we defined our alpha level as being 0.05 up above. We would fail to reject it all, which is a fancy way of saying the null hypothesis is probably true. We have to be less than 5%. Even though this is really close, it's not less than 5%. We have to be less than 5% in order to say that the null hypothesis is probably false. So in this case, we're going to say the null hypothesis is probably true, which the words we use in that situation is to fail to reject a null, which means there is no difference between the calcium and the placebo group in terms of reducing blood pressure in black men. So we have now completed this test. All 4 categories are there: state, plan, do, and conclude, and we have an answer. Okay, so take notes on this and see if you can solve the problems that I assigned that are similar to this.